When we as developers think about how we work with technology, we always have the feeling that we are the ones pushing the technology, right? We are the ones who are advancing, we are the ones who are making the progress. But the reality is actually that this works both ways. Because in the end, we can advance the technology only to our own limits. If we make things that are overly complex, difficult to understand, that also holds us back. So it's a two-way game here, that we push the technology, but in a certain way, the technology also pushes back. And in a funny way, we've actually made things harder on us, because what we realized is that the software delivery process, right? Like the classic idea of writing down the requirements, writing the software, testing the software, deploying the software, operating the software, that has a lot of friction, right? There's handovers. What if the requirements change, but we already coded? What if we have operational issues? We need to go back into development, right? There's a lot of friction in it. So we had the clever idea of saying, hey, if we push all these things into one team, so we're agile, we are DevOps, you build it, you run it, all these kind of things, right? Then we don't have these handovers, right? We save all these friction points. The downside is this reasonably good idea had an undesirable side effect. And that side effect is, if you're an application developer, now you also need to be a requirements analyst, you need to be a security specialist, you need to be a distributed systems developer, you need to be an operations specialist, and yes, you should also please code the application. So that's maybe a little bit much. Now, we're never short of good ideas to solve this, so when I work with customers, the general idea on how to address this is platforms. And it sounds a little bit like this. We call this buzzword bingo, right? We put the platform in place, it takes all the cognitive load away, it speeds up our development, it assures compliance, right? Basically, it solves all our problems. Now, what I want to talk about a little bit is how much of this is fact versus how much of this is fiction, and drawing a little bit back on the lessons that we learned when we built platforms, for example, for GovTech. So let's talk about why platforms are different and how they are different. So there is a little bit of magic here. It doesn't magically solve all your problems, but there's a little bit of magic. Platforms can do some things that other software layers were not as good at doing. And the core idea, again, isn't new, right? The idea is, can I build something once, right? I solve all the difficult problems once in some base layer, because not every software application is totally different, right? All of them needs network connection, read files, write to a database, I need logging, right? There's the things that pretty much every application will need, so why don't I put them in a common layer? And then as much as I can, I put another layer of semi-common things, maybe some common business logic I have. And the idea was that if I do this correctly, the development becomes very easy, because I've done all sort of the standard stuff, and all that the developers need to do is put the little cherry on the cake, and I have really high productivity, and I have really nice economics. Looks really good on paper or on slides, but I have a standard warning, and that is, when an IT architect shows you a picture of a pyramid, I always remind folks that people stopped building pyramids about 5,000 years ago, right? So there is likely to be some catch. And the catch here is that this model assumes that you can predict everybody's needs, because in order to reduce the effort to this little cherry on the cake, you would have had to anticipate everything they want to do, and in the end, they just flick a little switch. And I often like to take this to the extreme, where I said, hey, your framework should have one method. The method is called do the right thing. And you pass a Boolean parameter, and if you remember to pass true, everything will be fine. People say that's ridiculous. I'm saying exactly right. This doesn't work because you cannot and you do not want to anticipate everything. So platforms are different. Platforms still have the bottom half of the pyramid because you don't want to write your own protocol for reading disk sectors off your disk or your own network stack. In most cases, you don't want to do that. So you have a base layer. But the core idea is that on top of the platform, you create a broader playing field. You want more diversity. You actually do not want to anticipate what people build. Because if you anticipated everything, how are people going to innovate? Right? You do not want to anticipate. You want people to build things that you did not foresee, and that is actually called innovation. That's what we want from the platform. And that's why it's a different approach, and that's why it has a little bit of magic. So we like tests. So a test for a good platform is have people build something that surprised you. And we had the chat with my old GovTech buddies where sometimes we get funny surprises, like people used our CI/CD pipeline for data replication, and we were so impressed why they do 1,000 deploys a day. In reality, they weren't actually deploying, they were shipping data, so fair enough, they surprised us, right? Not exactly what we had anticipated, but we did pass the test of the platform. So there might be very positive surprises, there might be a little bit, odd surprises, but in the end, it means that people can use your platform in ways that you did not anticipate, and that is good. That's why you do want a platform. Now, another sort of fallacy we as software engineers tend to have is we always believe we invented everything. Right? Because we tend to be, or most of you tend to be young, right? There's new stuff coming out all the time, so always we feel like we're the first people who are encountering this. Now, luckily, in many cases, that is not true, so we can actually learn from the past. And it turns out that the platform concept transformed an entire industry about half a century ago, before most of us were actually born, and that's the automotive industry. I'm from Germany originally, so close to my home. Volkswagen and then many other of the automotive manufacturers had the idea of saying, hey, why do I need to build every car from scratch? Can I just reuse common components, right? Like the engine, the transmission, the suspension, right? Can I make different car models on this same base? So the idea started a little bit like the pyramid, right? Are there some common elements that I can just reuse? But what it has taught us was that the purpose was not to make fewer different car models. It wasn't actually a pyramid. They made more car models. Right? And this started in the old days with the Golf, Jetta, Passat on Volkswagen. BMW is a great example. When I was little, right, you could have a 3 Series, a 5 Series, and a 7 Series. There was 3 models that BMW made. I didn't get any one of those, but it's fine, right? That's all you could have. Now, if you're lucky enough to be in the BMW showroom, they will have a long list of models for you. There's a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8. Then there's an X1, 2, there's an M1, 2, 3, 4, 5. Then there's all the electric models. Then there's the Mini in many variations, and each of them is a different model. Each of them comes with different engines, different equipment, sunroofs you can have, whatever you want, right? So that would not have been possible without a platform strategy. So the idea is not to restrict choice, but the idea is to increase choice and product diversity. And that is the top half of the pyramid where things fan out again. So we have an example where this worked really well in the physical world. So if they can do it with steel and cars, we can surely do it with bits and bytes. Now, interestingly, the automotive industry also taught us the limits of this platform thing. So it can do a little bit of magic, but it can't do any amount of magic. And they tested this by having the clever idea. One day they said, hey, if it's much cheaper to make the common parts of the car once and make different models, isn't it even cheaper if we essentially make identical cars and we just stick a different label on it, right? For different buyers, we call it slightly different. We put a little bit of different options in this car. Now, this was a giant failure, and it actually has a name. It's called the Cadillac Cimarron phenomenon. Nobody remembers the car because it was horrible, except for the effect. And the idea was exactly this. General Motors has said, hey, if I want to make a Cadillac, the easiest way to make a Cadillac is I take a Chevrolet, I put all the options in, the power steering, the power windows, air conditioning, nice radio, all the options, and I call it a Cadillac. Why was this a giant failure? It's easy to see. Nobody wanted to pay a Cadillac price for a Chevrolet. So what they learned the hard way is that's what's on top of the platform is equally important to what's inside the platform. Basically, the mistake they made, they took the bottom half of this hourglass shape that we saw, and they tried to make the bottom half bigger and bigger and bigger, and the thing started to look again like a pyramid, and it was a giant failure. So what we're learning here, platforms are there. They create value by people building different things on top. This batch engineering is again trying to anticipate everybody's needs, and that is not a viable platform. But it's also an important lesson for platform teams, and that means the platform itself is only part of the equation. You're not making things for people, you're making it easier for other people to make things. Now, in one hand, that's fantastic because it has a huge multiplier effect. Right? If you make it easier for other folks to make things, right, your force multiplier, you made everybody more productive, and that's fantastic. But it also means that the whole equation only comes out if they build things on top. You can't do batch engineering. You can't just stick a label on it. People actually need to go and design another car model or another software application. So you're a little bit operating in meta territory. You're making a tool for other people to make things faster and easier. Now, if we think about how platforms do this, so let's leave the cars aside and zoom a little bit into software platforms. The most powerful thing that platforms achieve is that they can overcome past constraints. And that's a little bit of the magic that I'm referring to. And to me, it's a very positive thing because if we can do things that we used to consider opposites of each other, that is great progress, right? We can do things where we can have the left and the right, versus in the past, we always thought we have to choose one or the other. Because choosing one or the other, let's be honest, sucks, right? Let's take speed and quality, right? Why does it have to be slow to be good quality, right? There's never a happy choice, right? Either I'm fast with shoddy quality, or I build something decent, but I'm way too slow, or a little bit of both. Like, I will never be happy, right? So being able to have both is a fantastic maneuver. Right? And as architects and developers, we know how this works. Speed and quality comes from automation, right? Automated testing, CI/CD, short cycle times, right? That's how we get speed and quality. And platforms have another piece of magic. They allow us to harmonize, to standardize, so we use common elements, but they don't restrict choice. They actually drive innovation, as we just seen, right? Traditionally, standards are seen as things that restrict you. You know, here's stuff that you cannot do, right? Nobody likes the standards department to come to their development team because they said, hey, you can only use this database, you can't use that database. So it's seen as at odds with innovation. And platforms break through this, and that is indeed magical, and that is positive, right? This is stuff we like. We can have our cake and eat it too, because we can harmonize, but we can still innovate. Now, the way we can do that is, again, not entirely new. We have examples where we've done this before. So let's say you want more diversity in programming languages, right? Your teams are writing an application built out of different services on, for whatever, let's assume, good reasons people want to use or need to use different languages. Well, how do you enable that kind of diversity? Well, as architects, we know the answer. We make a common integration layer. We said, hey, you can use any language you want or any runtime you want, but you need to have this with HTTPS, OAuth, JSON, or protobuf, whatever it might be. So you lock down some choices, right? You harmonize things, meaning some choice goes away. So now it's HTTPS. It's not a different protocol, right? You have to agree. But in return, you get more options. I call this options trading. You give up some choices, but in return, you get more. So it's not actually restricting you. Net, you're gaining. But ironically, you're gaining by taking some choices away. Now, that is really this magical platform maneuver, right? That's why subtitle of my book is called Innovation Through Harmonization, right? Which is the opposite of what we normally think, because we think if everything is harmonized, everything is the same, and it's a bit harder to innovate. So we have living examples of how this works, and platforms really take this to the next level. Now, an important question to ask is who's building this platform, right? It doesn't build itself, and maybe GenAI will build it, maybe not. So for the time being, probably we still have a platform team. Now, interestingly, when I see platform teams being formed, they often come out of the infrastructure and operations team. Now, that is interesting because they're both the best and the worst people to build a platform. They're the best people to build a platform because usually the infrastructure and operation teams know the lower levels very well, right? So let's say you want to build a platform over the cloud. Well, those folks know the cloud extremely well. So they come with a lot of knowledge. But they're also, unfortunately, the worst team because they're used to working in a very different way. They're used to working in this pyramid model. They're used to restricting. They're not used to running as a product team. So you have the knowledge there, but the team has to be entirely different. And I see that being the death of many platform initiatives. Because the problem is, if you look at it from a high level, it looks the same, right? There's a box for application delivery, and there's a box with common stuff underneath, and that box used to be called infrastructure and operations, and now the box is called platform. So you're like, where is the big difference? The reason the difference doesn't show up here is because we're using a static model, right? It's a boxes and lines model for a dynamic process, right? I said at the very beginning, the platform takes away the cognitive load, it speeds us up. I call this the economies of speed. We want things to move faster. Now, if you want to explain how things move faster, we cannot use a static diagram, right? Like the boxes don't tell us how things move faster. We need to show the movement in our model. So once we do that, the difference becomes much more apparent, right? Once we have the inner and the outer loop of development, right? You build something, you deploy it, you see how it runs both from a technical perspective, like latency, uptime, error rates, but also from a functional perspective, like do users use it? Do people like it? Do they convert? Do they stay on the app, right? You get this kind of feedback, and then you fine-tune your application, either operationally or functionally, right? So error budgets, all these kind of cool things. In the traditional model, that cycle runs across different teams, so it has a lot of friction. Now, the platform team, remember, you're not building things for people, you're making it easier for other people to build things. You're not doing stuff for them. The platform team doesn't take tickets for, I need a server. The platform team doesn't take tickets for, I need this. It's self-service. So the platform team on the right-hand side is more like the axle in the system. The platform team makes sure that the development team can spin as fast as it possibly can. And every time the platform team finds itself in the loop, that's a little bit of a red flag. Now, you want to have a keen eye on the loop, and you want to take requirements, and you want to take input from the development teams, but as soon as you're in the regular cadence, you become a hindrance. especially if your platform scales, you will become a victim of your own success. So you cannot be in this cycle. Your role is to be the bearing or the grease on the axle that makes the cycle spin faster. And that is a very different way of working. Right? That's why I said the old blue box people are, from a knowledge point of view, very well equipped to run a platform team, but from the way of working, they need to make a 180-degree turn. It's a very different way of working, and if you depict it in a dynamic model, right, that becomes much more apparent. So we're zooming into the platform. So this platform has all these promises, right? It's gonna take complexity away, reduce cognitive load. So how is it gonna do that, right? And generally, we have a great tool to do that, and that is called abstraction, right? We abstract away some of the details. But it's easier said than done, and if you don't get this right, you either abstract too little or you abstract too much, and then you create dangerous illusions. You pretend the system to be something that it isn't, and that is also not appreciated. So a couple of failure modes that I see. The first one is people take the cloud, right? Take any kind of cloud service that you have, and people say, ooh, this cloud service has a few too many settings, right? It's, dangerous for the developers, too many things, it's confusing. So I'm going to default some of the settings. Some of them for maybe security or data privacy reasons, right? I peg it to a certain region, I enable data replication, right? I do a few settings. Now, that has a couple of problems, even though it's well-intentioned. The one thing is, if you have a jigsaw puzzle with 1,000 pieces and you say, hey, that's a little bit much for the kids, right? Let me make this easier for them, and you take 100 pieces out, you did not make it easier for them. You actually made it harder, because now they don't know which pieces are missing and which are not missing, right? So you're actually making it harder. And you can see this with the database, right? If you enable replication, maybe it has higher latency. Maybe developers should be doing inconsistent local reads versus consistent reads, because consistent reads are going to have much higher latency. Well, if they never knew that this is replicated, how can they decide? This abstraction is not holding. They need to know the settings you made in order to build good software against it. You didn't abstract anything away. So what we're learning, and is a couple of last car metaphors, you guys know I have a little bias for automotive metaphors, is naming things and abstracting things is very difficult if you build the thing. Because you're so enamored with all the pieces and all the stuff you did, and my going joke is, right, if the software engineers had named the automobile, I guarantee you it would be called, the piston, crankshaft, gear, wheel assembly, singleton factory something, right? It's like, that's how we think. Now, luckily, somebody came and named it after the purpose, which is something that moves itself, which is an automobile. But there's one more telling example of how you can tell a good abstraction from a poor abstraction, and one more car analogy, is what is that paddle called, right? The paddle that makes your car go. In the US, that's commonly called the gas pedal. And it turns out that is a very poor abstraction. Why? Talk about EVs, electric vehicles, right? Hopefully there's no gas in your batteries anywhere, right? There is no gas, it's not a gas pedal. So the proper name for this is actually the accelerator. It makes the car go faster. And you might, hey, you're splitting hairs here. No, it's not splitting hairs. It's about naming things after the purpose versus naming things after their function. And the tendency is always, the trap we always fall into, we name things after their function, after the ingredients, because that's what we build, but we should really name things after the way they're being used. So electric cars very much have an accelerator, they do not have a gas pedal. And that kind of wording matters. You need to look at the things that you build from the outside in. Operating systems are great examples of this. I often say the purpose of the operating system was not to default the drive letter when you're reading raw disk sectors. So that's kind of convenient. I defaulted, same defaults we call it, right? It's like, hey, by default, I'm reading the disk sectors from disk 0 for you, so I did you a service by you not having to set the drive letter. People would have said, like, that's not that useful, right? Instead, operating systems layered many different abstractions over disk storage. Directories, files, symbolic links, streams that you can read, right? No network, no disk works in streams. It all works in packets and sectors, right? This is an abstraction that's very useful. It makes us more productive. But see, the vocabulary has changed. I'm talking about get next byte. I'm reading from a stream. I'm opening a file. Nobody talks about disk sector. So the language has changed, and that's what gives the abstraction. Basically, if you use the same base vocabulary, by definition, you didn't build an abstraction because you didn't abstract anything away. You might have still made it more convenient, also useful, but you didn't abstract it. Like abstraction rely on a new vocabulary, a new mental model. So this is a common failure mode, right? And I see this with cloud providers all the time. They say, hey, we have this fantastic abstraction, and it's called Lambda, SQS Lambda, or whichever one you want to pick. I'm like, how can this be an abstraction? Because if I don't know exactly what Lambda and SQS and Lambda and whatever other service is, I'm no wiser than before. It might be a convenience, but I didn't abstract anything because I'm required to know all the details in order to use this so-called abstraction. So the test here is, if you need to be familiar with all the lower level vocabulary, probably it's not a great abstraction. Now you may ask, well, so where do I get this abstraction from? What should I do with my cloud services? And the bar is relatively high, but it can be done. Think about naming your services in a way that the cloud provider fundamentally would not be able to do. And now you're going to go, hold on, they have a lot of money, they have a lot of people. How can I do something that they cannot do? Very easy. You can name your service database that contains customer data or citizen data. Right? That is something the cloud provider will never have as a service. It has all the dials and settings and replication and security settings, encryption at rest, encryption in transit, right? They have all the bells and whistles, but you will never see a service from them that is called database that has citizen data, right? Because that relies on your jurisdiction, your locale, your rules, your internal governance. So once you understand your domain, like what is important to you, you can start naming services in a way that a cloud provider fundamentally cannot. Now that is power of platforms, right? You're not trying to dummify things that the cloud providers have already built. You're layering something on top that they could not have done. And that indeed is very powerful. Two last things I have. The one is, this isn't easy, obviously, right? It's pretty cool magic, right? But it's not easy. So one way that you can think about this more easily, or one way that can help you design the platforms, is using metaphors. Metaphors are borrowing things from another domain to apply to your system design. So you might ask, what does a platform have to do with fruit salads and fruit baskets? Actually, quite a bit. A fruit basket is a collection of fruit. It's nice, it's cute, it's easy to buy, but at the end of the day, you just get fruit. A fruit salad is a different product, right? You can take a fruit salad to a picnic or to an airplane because you don't need tools. You can have watermelon in the fruit salad, and that's very easy. If you have watermelon in your fruit basket, that is pretty tedious, or jackfruit, let's say, right? The thing weighs 25 kilos. So a lot of platforms start out with say, hey, we give you like Jira and Confluence and a few other things. That is good, but that is fruit basket, right? You should give people a new product. You should give people the fruit salad, something highly cohesive that enables new use cases. Like you should be able to do more with this platform than just with the pieces. And the fruit salad metaphor captures this nicely. I once talked to a customer where the head of platform engineering renamed their title to fruit salad maker, right? Because they liked this kind of metaphor. Second metaphor that can help, so you're building an in-house platform, and you might be building things that cloud providers build later on. Like when I built platforms originally, it was a lot of CI/CD, right? Build pipelines, right? In the early days. Now almost every cloud vendor has something like this, or also the GitHubs and GitLabs of the world, right? They all have actions and CI/CDs. So basically, they build things that I had already built. Now you have two choices, right? Do you throw away what you built? No, or do you keep it? So I use the metaphor of, in this case, positively rising ocean levels, right? The cloud provider's building stuff so the water level goes up. So if you keep your existing platform, your platform is underwater, right? And nobody drowns as a submarine, right? It's nicely submerged, right? But you gotta admit that your economics are much worse than the cloud provider's economics, because they build CI/CD pipelines for the whole world. You know, you're just building maybe for a few hundred or a few thousand developers. So the metaphor helps people get decision discipline. Because here's what happens. In the beginning, everybody says, I want to be floating, right? If they build the same thing that I've already done, right, then I'll do the next cool thing. I build the stuff that they cannot build, as we saw, right? Everybody says, I want to float. But when the day comes, everybody gets wet feet, so to speak, because everybody like, oh, what about all the money we invested, all the platform we built? We need to migrate our users, right? And then immediately people are like, maybe we stick with what we have. So they're changing their mind, and this metaphor can help people keep this decision discipline. You can say, hey people, didn't we want to float? So now why are we not floating? Because we're worried about sunk cost. So with that, I only owe you a few final tips. So you might have seen the impossible object that I showed, the illusion. So the thing is, if you think outside of the box, impossible stuff can be built. So this thing is real, right? You just need to be very clever. So platforms can be built and they can have this magic, but you need to think a little bit outside the box, and this is how the magical shape works. Second piece of advice that I have for you is, a lot of platform teams start with a story on the left. They're going to say, dear developer, I'm going to make the golden path, the superhighway. Your productivity is going to be unlimited. And yes, there's going to be a little bit guardrails, but don't worry too much. What they deliver in the end, they build giant guardrails, right? Because governance, funding, all the kind of things, right? But they had no more money to put the pavement down. So don't be that platform team, right? Don't promise the superhighway and deliver the cattle path. And it would be impossible to make any talk without Gen AI, so I have a very last piece of advice about Gen AI. Do I still really need to build platforms? Isn't Gen AI magically going to make my crappy API usable because the developers don't write the code, right? Gen AI will write the code. I would say not quite, right? If your APIs are a little bit smelly, right, and Gen AI writes a lot of this code, you probably end up with a lot of smelly code. So the good news is platforms still have a place to be, and human intelligence and abstraction is something that Gen AI doesn't do well, at least yet. So there is a lot of room for platform builders and platform abstractions. So I like hanging out with you folks. I'll be around all day. Here's my LinkedIn profile. Connect with me, come by and chat, and thank you so much.